In this video, we'll go over computing the determinant of a 3 by 3 matrix. So consider the following matrix listed here as A. Now, just as a spoiler, we're going to need to compute the determinants of many 2 by 2 matrices in the process of finding this determinant of a 3 by 3. So we're going to break the problem of determining the matrix of or determining the determinant of a 3 by 3 matrix into that of a 2 by 2 case. So the first thing we get to do is choose a row or column in which to expand across. Now in this case, I'm just going to take the first row. It won't matter which row or column we use, as long as we follow the process of finding the determinant the correct way. So the way in which determining this or finding this determinant works is we take the first value that we are going to expand across. So in this case, consider the 1. And actually, let me move some things around here. I'm going to paste our matrix down below and move this other item appropriately. So if we choose to expand across that first row, let's take the first item in that first row, which in this case is that 1. Now the other items in that same row and column, we effectively get rid of. So what we're actually looking at then looks like that 1, and then a submatrix inside of that greater 3 by 3 matrix. And that submatrix, we actually take its determinant. So notice those vertical lines, meaning determinant, and we find the determinant of that submatrix 1, -1, 4, 0. Next, we'll move on to the next item in that first row that we're expanding across. So remember, we're expanding across that first row. We'll take the second item now, which is that 3. We cross out the remaining items in that second row. And then we look at the matrix that is still there, which in this case is the matrix 2, -1, -2, 0. And again, we take the determinant of that 2 by 2. So we'll do the same thing for that last item in the first row, that 5. And again, we're expanding across that first row, but now we're considering that last element, which is that +5. We cross out the remaining entries in the same row and the same column, and we see that the remaining submatrix there is the matrix 2, 1, -2, 4. Okay, so at this point, we have these products of some number and some determinant of a 2 by 2 matrix. But we have to be able to combine these in some way. So that's what we're going to do next. And the way in which we combine these is basically depending on if we are on an even row or an odd row. So for example, when we're expanding across an odd row or column, we use a plus sign in front. When we're computing or expanding across an even row or even column, we use a minus sign. So in this last case, we're in the third column. We use a plus sign because it's an odd number. So that's how we determine the plus or minus in front of those 3 sequential products of a number and the 2 by 2 matrices, the determinant of the 2 by 2s. So let's actually finish computing this. So this gives us a 1 times the product of 1 and 0, which is 0, and then we subtract off the opposite case, which is -1 and 4. And we'll do a similar thing for the others as well. So minus 3 times the determinant of that 2 by 2, which in this case we have another 2 times a 0, so that gives us 0. We subtract off the product of that reverse diagonal. And then finally we do the last determinant down here. So 5 times the determinant of that 2 by 2, so we have the product of 2 and 4. And we subtract off the reverse product, which in this case is a 1 and minus 2. So lots of arithmetic to find these determinants, but it always breaks down from a 3 by 3 case into 2 by 2s. If we did a 4 by 4, we would see the 4 by 4 break into 3 by 3s and then 2 by 2s. And you see this hierarchical structure of how to compute determinants. So in this case, we have that 1 times that determinant of the 2 by 2, which comes out to, that is 0. And then we have a minus 1, so a 1 times 4. We subtract from it the 3 times 2 times 0, which is 0. And then a minus, which gives us a minus 2. And then finally we add plus 5 times that determinant of that last 2 by 2, which in this case is an 8 minus a minus 2, which is plus 2. So that gives us the product of 5 times 10. So if you do all this arithmetic out, we find out that this is 4 plus 6 plus 50, or this is equal to 60. And that's how you compute a determinant of a 3 by 3 matrix. Now note, we could have expanded across a different row and did a similar process, or a different column. What may have been easier in this case is looking at this matrix is if we expand across a row or a column that has many zeros in it. So maybe taking this last column and expanding across instead of that first row, or expanding across, say, the bottom row, rather than expanding across the first row like we did here. I hope this helps you determine the determinant of a matrix.